Thank you. Hi. Do you all hear me? Oh, that's fun. I feel very self-conscious about the Britney Spears microphone, and I hope it works with the rest of my face, you know. My name is George. This is my Twitter handle. If you don't see it, it says Yuki Fartlek. There's a story behind it. It's an embarrassing story. If you want to know it, you can talk to me afterwards. And this is, by the way, the emoji that I worked on. I work on in the core services team at Twitter, and we're re-implementing the private API, and we've chosen GraphQL as a technology to do that with. So what I'm planning to talk about right now is what kinds of challenges we had introducing GraphQL at a company the size of Twitter, and obviously replacing an existing private API with it. I'll talk about the benefits and the drawbacks of current approach. Then quickly walk you through how we've implemented GraphQL at Twitter, and then we'll dive into, I hope, an interesting problem of implementing GraphQL subscriptions, and finally, time permitting, maybe just go through a few tips of running your own GraphQL setup at your own company. So first, very quick interactivity. Who here considers themselves to be sort of like a back-end engineer? Nice. How about front-end engineer? Nice. How about full stack? Oh, that's cool. So yeah, I hope everyone will take something out of this. But next, hands up if you're using, like just in any way, using GraphQL, playing in your own projects or in any way. Oh, this is fantastic. How about keep your hands up if you're using it in production at work? Very nice. And how about using GraphQL subscriptions? Not necessarily in production. Very nice. Cool. That's very interesting. So Twitter is famously a microservices company. I think there's like everyone knows the story of how we grew out of the monorail and had to rebuild everything in microservices. I'm not going to go into the history. The point is, moving over to microservices has allowed us to scale both technically and organizationally. And the thing is, the amount of it's sort of like a big company, so the amount of services you never know the exact amount of services that are running in production at any particular moment. This is counterintuitive, but services are going up, coming down, and being replaced by other services. But I did some counting in our mono repo. I basically counted the number of deploy configs, and those were around 2,000 at the time when I did it. Oops, doesn't do what I want it to do. So the types of services that we operate, we have HTTP services. Those are the services that you as a client would be talking to. Those are typical, JSON over REST over HTTP things that you're used to, where you just take a JSON blob and hurl it over the fence over to the clients and forget about it. The second type of services, which is basically the meat of services at Twitter, most of the services at Twitter are Thrift services. Those services are inside of the private network, and the only way to get your hands on them is to expose them through the HTTP services, the data that they expose. So Thrift is a remote procedure call system, RPC system. It's been, as far as I know, developed at Facebook and then open source, and it's part of Apache Foundation. This means that most of the communication that's happening at Twitter between services is typed. So those are obviously not GraphQL types, but those are types, and this is like a thing to keep in mind. By the way, if you're working on your own microservices architecture, I can really recommend looking into things like Thrift, not necessarily gRPC. Or they give you a lot of benefits. They allow you to generate your server and client code. They let you just focus on whatever business logic you're actually working on and forget about, parsing responses, producing requests and things like that. And then finally, we have a layer, like a data storage layer. Those are most probably some kind of a memcache or a key value store. So this kind of architecture has let Twitter migrate away from the monolith and let it scale various functions separately, as well as having multiple teams working on different parts of the system, not step on each other's toes, which is great. But then, on the other hand, the problems that we faced is this architecture doesn't really support fast prototyping, developing new features quickly, playing with them, and maybe throwing them away. Mostly because if you want to expose something new, you have to touch all of this, and it's a pain. For example, when we teach our new hires, for the first week, they're basically going through a new hire orientation. One of those days, they're implementing a new feature. They're trying to add a new field onto a user. So, which is a great way to onboard an engineer, because they have to figure out where to store it, figure out how to read it via a Thrift service, and how to even spawn a Thrift service, and all kinds of things around them, how to deploy it, and then how to pipe it through the HTTP. This is a very good problem to onboard an engineer, but it's not a very, but for the same exact reason, it's a very bad experience to prototype a feature, exactly because of that, because you have to touch everything, and that's maddening. This is where GraphQL, we decided that GraphQL is going to come in and save the day. We decided that it's going to live among other services, and it's going to be both an HTTP and a Thrift service. It basically uses a range of data sources, the existing HTTP endpoints, as well as Thrift services, and the data layer that I forgot to mark over there. So how did we do this? For this, we basically leveraged an existing technology within the company that was built for something very different. And I want to tell you about that technology. It's called, we call it Strato. It's not open source, mostly because it's extremely tied into the Twitter infrastructure and nonce, and it's very just, it's basically like the essence of the Twitter ecosystem. So it's probably not likely to be in open source, but I think it's a very nice idea, and it's interesting to talk about it as a technology. So Strato is a federated database that brings together multiple data sources so that they can be queried and mutated uniformly. And what does that mean? The federated database, you could also say virtual database. What I mean by that is the tables in the database are not really tables. They're backed by some other data source. That data source can be a Thrift service, can be a separate data store like memcached, or a key value store like, I don't know, Cassandra or whatever, or an HTTP service, as long as you provide some kind of schema around how to parse and produce responses. So it's basically a catalog of all the things, all the services there are at Twitter with their types, in a way. This sounds very similar to what GraphQL is, right? GraphQL brings together multiple data sources so that they can be queried and mutated uniformly. Exactly the same idea. So philosophically, Strato and GraphQL were very similar, except Strato has been built for a very different purposes, and it wasn't really focused on building client applications. It's also not exposed to the outside world in any way. So it existed at Twitter for a while, and it's the layer that we decided to use to power our GraphQL API. It integrates tightly with all the Swift services, and this approach has given us basically a lot of power because Strato has been at Twitter for a long time. A lot of services have chosen to create their own what we call columns to add their services to the catalog. The catalog is basically the catalog of all the things that are added to Strato, and so basically, if we were able to leverage that to produce our GraphQL schema, we basically could produce a full schema of all the things that people have already added. So this is what we decided to do. The way Strato knows about the data sources is via config files written in something we call StratoQL. This is an example of a StratoQL. It's because Twitter is a Scala shop, we basically try to do things that look like a Scala. So it's a little bit like Scala, but it's not Turing complete. You can do whatever you want. It's not aiming to be a fully programmable language. It just aims to be enough to query to be a query language. So the job of Strato is to collect these kinds of column configs and put them into the catalog. And what our team then does is take that catalog and tries to use it to produce a GraphQL schema. Basically, the details aren't very important. The main takeaway point is that this is a config. This is like a one-file config in sort of like a scripting language, like a query language. So you don't have to think about so many things. You don't, as a person who writes one of those, you don't have to think about CI jobs, deployment configs, metrics, dashboards, runbooks, on-call, rotations, creating new services, like all of those things. You just don't even need to think about the config. Once you land it, it's going to be auto-deployed, and by magic of our services, it's going to get exposed through GraphQL. So your job when you're prototyping a new feature is to just create a working config. And basically what we ended up adding is a new config annotation that allows a column to be exposed to our services. All of this makes sense, more or less, right? We take the catalog from some ancient system and we produce a new shiny GraphQL. So let's talk about subscriptions a little bit right now. Does everyone know what GraphQL subscriptions are? Not necessarily. Okay. Who has seen TweetDeck? Not too many people. TweetDeck is Twitter's product for power users, I want to call them. It's heavily used by journalists, for example, or people who are very into memes or cats or things like that. I have a video of I did it yesterday of a TweetDeck column working. So you can have multiple sort of timelines in TweetDeck as opposed to one timeline in the Twitter main app. And here I'm typing cat over there, and I'm being hurled, all the cats that are being posted onto Twitter in basically live. As they're being posted, they're being hurled into my column. So this kind of streaming system is what GraphQL subscriptions are very good for. The system that TweetDeck has been using was being deprecated and was supposed to be shut down April last year. And so we decided, as a young team, we decided that it is our perfect opportunity to help them out and put ourselves on the map as a new team. So what happens in a GraphQL subscription? Clients subscribe to an event from somewhere with a GraphQL query, and they receive payloads of executing that query against that event. So the payload is basically a result of executing the query against the event. Our systems are basically, we have isolated them in a very similar way as the color coding here happens, because so we have systems that take care of the events, systems that take care of executing queries on those events, and systems that take care of delivering the payloads. The reason is those systems are basically extremely different and scale very differently, so it makes sense to have them in different places. So first, let's take a look at the events. Twitter already has an extensive pop-up system, like a lot of companies do, and it already handles a lot of events flowing through the system. It's called PubSub. It's called Event Bus. And before it has never been exposed to our clients, and basically exposing it to our clients was what we wanted to do here. Event Bus is a distributed queue system. You can think about it as any other distributed queue system you've seen before. Event producers are services that publish events, and then subscribers subscribe to those events and do things with them. We basically built one of those subscribers. We called it GraphQL Subscriptions. And as I said, the service is separate from GraphQL API, mostly because it's a stateful service. It needs to know who is subscribed to what, as opposed to GraphQL API that doesn't need to know all of this stuff and is just concerned with executing the queries. So this is the first building block. We get event producers throwing events already onto Event Bus, and we just add a new subscriber called GraphQL Subscriptions. Let's look at how we execute, now that we're receiving those events, how do we execute queries against them? So this is actually where our GraphQL API shines, because it actually does that already, and we don't really need to build anything new for that. We had to add a thrift endpoint because we wanted to not only execute GraphQL queries, but also execute them against the particular events. And we wanted to execute them as a user, so that GraphQL API basically stays stateless. It doesn't need to know who wants to know, right? And the who wants to know part lives in the subscriptions system. So that's why I said that GraphQL is both an HTTP and a Thrift service. Here is this JSON bundle basically is an example. The API will run the query against the event from the point of the user. So again, the reason we have a particular user is, for example, if I block you, then I don't want my cat photos to be showing up on your TweetDeck stream. But if I don't block you, I still want all my cat photos to be liked by you and cherished. So that's basically the concern. So with this in place, we can, after we've received an event, we can call out to GraphQL API and get back the result, the payload. What do we do with the payload? Somehow we need to deliver that payload to the user that has requested it. And the user has, they have made the requests, and then events are coming through at some point in the future. The user doesn't necessarily hold a connection anymore to our service. In generally, streaming, like streamed event delivery is a kind of like a hard problem, so I've heard. Particularly, taking into account that there are multiple DCs, and the client might be just like walking over somewhere, and then boom, they're connected to a different the data center, and like all of these things. Just like generally, distributed systems are hard, and in choosing how we what kind of system we're going to build, we really wanted to make sure we're not going to have to reinvent the wheel. So we searched for basically solutions that were already there, and we found a technology that we call Live Pipeline that was already in use at Twitter. The technology basically, if you look at your timeline, you sometimes see likes numbers go up and down, or when you DM with someone, you can sometimes see typing indicators. So that's basically already handled by that system. The way this happens is the client subscribes to a topic and establishes a streaming HTTP connection and gets back sort of payloads with the topic. To deliver GraphQL subscription payloads, we use a unique live pipeline topic per GraphQL subscription. So a topic is sort of like a thing that describes that someone is subscribed to something. We basically combine and hash a bunch of data about subscriptions to create the topic and give the topic back to the client so they can subscribe to Live Pipeline. So when a client initiates a GraphQL subscription query, this is a GraphQL subscription query, we make sure for them to ask for the topic and the rest of the query of how to hydrate the incoming event. And then the client gets back this kind of response with the topic. Then they can use that topic to subscribe to Live Pipeline and get back payloads as soon as events are coming in. So let's just tie everything up together, because I feel like I've been talking about different parts of the system, and it makes sense to just bring everything up together. The clients makes a subscription request to GraphQL API. GraphQL API might let the event producer know that there's a new subscription. If the event producer is interested in that, it might not. But the client gets back the response with the topic. The client then uses that topic to subscribe to Live Pipeline. And then as the events are starting to stream in through the event bus and into our subscription system, we start executing them against our API, the Swift endpoint that we've just defined. And once we get the payloads from there, we push them onto Live Pipeline, and those basically get delivered to the client. So the client makes one request, subscribes to another thing, and then just basically waits there. That's basically the whole idea. Some very quick tips about things that we've learned by running a system like that in production. As I already said, we are a Scala shop, and we're using the Sangria library, which is an implementation of GraphQL spec. If you're a Scala shop as well, I don't think there's any cooler kid on the block, so please give it a try. The maintainer, Oleg, is amazing. Another thing that we've learned, which in hindsight is quite obvious, is that when you operate a bunch of REST services, you alert and graph statuses that your service returns. You want to make sure that you have good success rate. You want to make sure that as you deploy things, 500s are not creeping up, 400s are at a relatively stable level, things like that. With GraphQL, since most of the responses that you're getting are a 200, there's stuff in there. And you might get a 500 if stuff really goes bad, like the whole service is just basically feeling very bad. This kind of alerting is pretty much useless. So by the way, what I mean by What I mean by GraphQL always returns a 200. Here's an example. When you want to, like, for a user, get all their tweets and display them in some way, like show a text and an avatar of the person who has tweeted that tweet. And inside of those tweets, there may be quoted tweets or retweeted tweets. And you want to make sure to hydrate those as well. So you basically fetch a user, you get the list of their tweets, and you start hydrating each tweet in turn, and then maybe some of those have a quoted tweet, and maybe some of those are missing. It would be a horrible user experience to just throw a 404, because something somewhere down the line has failed to resolve. Instead, what we want to do is we want to produce as much data as we want for the user and just say, OK, like this we couldn't fetch, and here's why, and then this we couldn't fetch, and here's why. So those would be partial errors. And so instead, what we're doing is we're counting the partial errors, and we're making sure that partial errors are on the same level as they are before and after a deploy, things like that. Another thing we've learned is that when you give a client a tool, they're going to try and abuse it as much as possible. This is a pathological query that tries to fetch all the followers of a user, and then for all of these users, try to fetch all of their followers, and then for all of those, fetch all of those followers. That just won't work. It will probably take way too long, probably will take a lot of systems down or just put them under undue stress. We shouldn't be able to allow clients to execute these kinds of queries. So we're protecting from that in two ways. One is we're basically looking at the depths of the query and disallowing queries that are too deep. And by too deep, we decided on the threshold. And then the library that we're using allows us to calculate the complexity of the query. So we're using that as well. And then our last line of defense, because we're building an API for our clients, and we want them to experiment as much as possible and not be like extremely constrained. We want them to be able to try to execute these kinds of queries and learn that they're wrong, but we don't want them to be in production. So we've basically built a system that requires client applications that go into production to submit their queries into our sort of query database. And then they get back sort of like a hash like this, and then they can use that hash in their production requests. That's obviously, they can, parameterize it with variables and like inject different variables, because that would be outrageous not to allow them that. But this basically makes sure that, firstly, because they can only submit their queries from within the VPN, we're making sure that no one from outside of Twitter does that, just because they cannot. And then, secondly, we can do all kinds of analytics on these kinds of queries. We know exactly which kinds of queries are running. We know some of their characteristics. If ever we decide to change the schema in a drastic way, we can just theoretically go in and like change all of those queries and make sure that old clients are still working. So that's other thing that we've been doing with some success. And I'd like to finish with why I think GraphQL is exciting for us. In the big picture, I see GraphQL as an enabling technology. This means that it can drive radical change in the capabilities of a user or a culture. Because it is so different than what we were using at our company before, it allowed us to build all kinds of interesting things that we couldn't have built before. One of them I've mentioned, analytics on the queries. The other one, we know exactly which clients are using which fields and when and for what and how long it takes to resolve each of those fields. When you're a backend engineer and you like maintain a REST service, and you're like, I there's this field, and I was so stupid to add this field. I wanna remove it. Like, you don't know if you can remove it. You don't know if any of the clients are using it, and even worse, you don't know if any of the clients in the past have been using that field. So that if you remove, maybe your current clients are fine, but then some client from a person who hasn't updated their phone in like 25 years is gonna break, and they're gonna start sending you emails. This kind of technology basically lets us know like exactly how many requests each field is getting, which is super exciting. It lets us deprecate fields so that they're basically hidden in the schema. The old clients are still going to work, but the new clients will just not be able to use it because they're not going to see them in the schema. So in that way, GraphQL produces all kinds of what we call adjacent possibilities in not only on the back end, but on the front end, in the client, in the tooling, all of that. Thank you. If you found this of any use, please come talk to me afterwards.
Thank you, George. So we have time for about 2 to 3 questions. So if you have a question, please raise your hand. We will come to you.
Thanks, awesome talk. Why do you check for depth and complexity and not, shouldn't the complexity check automatically resolve any depth checks?
That's a good point. Yeah. I mean, yeah, we've basically added a bunch of things because we saw that they were there, and we were like, cool, yeah, this looks good, let's add it. That's a good point. Yeah, I think, yeah, totally. Complexity is a subset of that should contain depth. Makes sense, I totally agree.
Any more questions?
There's one over there.
Do you store the full history of this registry of all the fields, etc.?
Full history.
So do you know at any point of time which fields were used or which exposed or something like that?
Right. So we're using our monitoring system that's called Mon because no one has imagination. But anyway, and we're basically sending data about real-time usage there. That retains the information for 2 weeks. So we know the usage for, that's per minute and per second usage, and then per hour it retains, I think, for a year or something like that. So a year back, I can see how many times per hour a query or a field has been used. And then another thing we do is we log a bunch of usage and ship that to HDFS, and that is held for like a long time, and there is like jobs, like scalding jobs that process that. Those are not owned by my team, but we have access to that. Theoretically, like if we want to look into more than a year ago, yeah, that's more or less the situation.
Cool. A round of applause for George, please.
Thank you.
This conference has been gradually getting better for me. The quality of the lineup is usually really, really good, and this is something I'm really saying thumbs up.
They're really trying to get speakers here that are pushing to the future of web technologies.
I just feel like it's a very community-driven conference. It also has a lot of quality, and people are just nice. Hi, my name is Sarah, and this is AgentConf in Dornbirn.
Amazing venue. Austria is beautiful. Meeting all of the people in the community and getting to go and hang out and ski.